Welcome to Tebi Talks. In this video, we are going to look at Newton's laws of motion. This is Newton's laws of motion. Now, one might be wondering, who is Newton? Newton is one of the great scientists that have ever existed, and much of the physics that we are doing is termed as Newtonian physics. And for that reason, we are going to look at his laws. This guy made some discoveries made some observations, and from these observations, he came up with laws that were found to be valid. Now let us look at law number 1. The laws of motion by Newton, they are three. Let us look at law number 1. What does this law state? We say that this states that a body continues in its state of uniform motion, its state of rest, or uniform motion in a straight line, unless acted upon by an external force, unless acted upon by an external force. So this force that acts on this body can either be a pull or a push. Okay? The force we are talking about here can either be a pull or a push. That is that law. This law is sometimes called the law of inertia. It is also called the law of inertia. The law of inertia. Now, what is inertia? What is inertia? Inertia is the reluctance of a body to stay in its state of either rest or motion in a straight line unless acted upon by a force. For example, if I rest this marker here, if I rest this mark of mine here, let me see if I can rest it. If I rest it there, this mark will stay at rest the way you're seeing it forever and ever, unless you act on it, unless you give it a push. So now, when it is resting here, when you see this body tending to be in its state of rest, that one is what we call inertia. It is the reluctance of this mark of ours to remain at rest, because it is now in a state of rest. It would remain there if it is not pushed or acted upon by any external force, and that's what we are calling inertia. Or if this pen is falling from up here freely, and this pen goes downwards without meeting any obstacle, this pen will continue moving downwards infinitely unless it collides with a certain body on the way. So the body with which it collides with will have given in some kind of force. So let us define inertia, and we say that this is the reluctance. This is the reluctance of a body to stay in its state of rest, or uniform motion in a straight line, unless acted upon by an external force. And we said that this force can either be a pull or a push. So we can also write that this force is either a pull or a push. That is the nature of that force. That force can either be a pull or a push. That's what happens. And this law, the law of inertia, explains various scenarios. One of the scenarios it explains is that when you're seated in a vehicle and you're traveling, when a driver suddenly applies the brakes, you see yourself, you throw yourself, the upper part goes. What causes that? What causes that is that when you were seated on the chair, your body was in a state of rest. The lower body was in a state of rest. Now, when the car suddenly stops, what happens is that this upper part that was in motion will want to continue moving, and therefore you're thrown forwards when this driver suddenly applies brakes. The same thing if you're standing in a train. You are standing in a train and they begin it. When they are beginning it, you tend to fall back. Why? The reason you tend to fall back is that your legs are in contact with the train and they were in a state of rest. But when the train begins moving, the legs which are in contact are also moving. But now the upper part was in a state of motion, it will want to remain in a state of motion. So all those scenarios are explained by the first law of motion. Let's look at law number 2, Newton's second law. Now, what does Newton's second law state? This states that the rate of change of momentum, the rate of change of momentum of a body is directly proportional to the applied force, and takes course in the direction of the force, Now, we are saying that Newton's second law states that the rate of change of momentum is directly proportional to the applied force and takes a course in the direction of that force. What do we mean by this statement? That and what is change of momentum? Change in momentum is the final momentum minus the initial momentum. But then another thing should be, what is momentum? Because now we are talking of change, rate of change of momentum. Do we know what momentum is? Momentum of a body is the product of force. You can say this is the product of mass of a body and its velocity. Okay? That is what we call momentum, i.e. momentum is equal to mass times the velocity, which can be mu, where m is mass and u stands for velocity. So now when we say the rate of change of momentum, what do we mean by rate? And we are saying change in momentum. What is change in momentum? Change in momentum is equal to final momentum minus initial momentum. Now, when we talk of rate of change of momentum, we mean final minus initial momentum out of time. That is what we mean by rate of change of momentum. And this second law of Newton leads us to a derivation, or leads us to the expression where we say that force is equal to ma. We use Newton's second law to derive that expression. So let's try deriving the expression. We are going to try to derive the expression. Now, we can write and say deriving F is equal to ma. So here we are basically using the second law of motion. So let us begin and try to say, we say that consider a body of mass m, moving with a velocity u and attaining a velocity v in time t. Now, we are considering that body which has mass m moving with an initial velocity u, and then it is attaining a final velocity v in a time t. We know that from Newton's second law, now when does this happen? When does the force, the velocity change? When a force F is applied. This is happening when a force F is applied. Now, from Newton's second law, we are saying that the rate of change of momentum is directly proportional to the applied force. So now, if the applied force is directly proportional to the rate of change of momentum. Now, what does this tell us? What is change in momentum? Change in momentum. Change in momentum is a final momentum. Minus initial momentum. Now we said momentum is mass times velocity. Say It is mass times what? Times the velocity. Therefore, this tells us that force F is proportional to mv minus mu out of time, which is the rate out of what? Out of time. Now, what does this one drive us to? To remove the proportionality sign, we put a constant. Now, when we put a constant here, we remove the proportionality sign and we get equal sign. Now, m is common, we can pull it out, and in brackets, we are left with v minus u out of t. But we should recall, or we know, that from the first equation of motion, or from the definition of acceleration, acceleration is the rate of change in velocity. So this implies that our F is equal to kma. But experimental results show that k is 1. Experimental results prove that k is 1 from experimental result, and therefore this shows me that my force is equal to ma. Now, this is the force that we have, and this force must be the resultant force. We can also write and say that this force must be the net resultant force.